Most current systems provide cooling by air. However, water can be an alternative to air in a lot of applications. Let's see how air compares with water as a cooling medium. Water is 832 times denser than air and has approximately 4 times the heat capacity as air. Effectively, one must circulate 3,300 liters of air as opposed to 1 liter of water to absorb the same amount of heat. Sample this. To provide 100 TR or tons of refrigeration worth of cooling, one would need 40,000 CFM of air compared to just 32 CFM of water. Moreover, the air-cooled system would need 6 times more power than the water-cooled system for just pumping. Clearly, water is a much more potent cooling medium, and cooling by water is more efficient than cooling by air. Radiation, or radiative heat transfer, is what occurs when heat radiated from one body is absorbed by another. We feel warmer around a fireplace because of the heat radiated from the fireplace to our body. Mean radiant temperature and perceived air temperature. One of the fundamental properties of heat transfer is that heat flows from a hotter body to a cooler body. In any room, there is constant heat exchange between the walls, roof, floor, people, and other objects. The weighted average of the temperatures at which the surfaces of all such objects in a room radiate heat is the mean radiant temperature. Mean radiant temperature quantifies the influence of surface temperatures on human comfort. For example, a hot roof, windows exposed to direct sunlight, etc., will increase the mean radiant temperature. The higher the mean radiant temperature, the cooler the air required to achieve thermal comfort. On the other hand, if the mean radiant temperature is lower, occupants can feel comfortable at relatively higher air or space temperatures. One of the ways of achieving efficient and sustainable cooling is therefore through a system that lowers the mean radiant temperature, which will reduce the amount of energy required to provide thermal comfort. Panels. In radiant panel type cooling, copper tubes may be used for circulating chilled water. Piping. Loops of cross-linked polyethylene pipes are embedded in walls, floors, ceilings, and chilled water is passed through them. Control system. Along with the switching controls, these controls may also be used to regulate conditions using inputs from various sensors. Chiller. A chiller is used to cool the fluid medium to required temperatures. Other components. Other components like manifolds, valves, pumps, etc. complete the layout. Chilled water from the chiller goes to the manifolds and is distributed through the grid of pipes installed in the room. The chilled water in the pipes then absorbs heat from the ceiling or the floor, making it cooler than the objects and the occupants in the room. The resultant temperature difference ensures that heat from the bodies is now radiated towards the cooler building components, leading to a sensation of thermal comfort. Radiant floor cooling. As the name suggests, pipes embedded under the floor cool the space above in this layout. Radiant ceiling cooling. Installed directly below structural ceiling, panels with embedded pipes or pipes attached to the ceiling and covered with plaster. Radiant wall cooling. Small diameter pipes are attached to walls, then plastered over, or panels with embedded pipes are mounted on the walls to achieve radiant wall cooling. Pipes may be run from the floor as a same circuit, or a distinct circuit can be installed. Latent heat load management using a dedicated outdoor air system. Comfort is as much about humidity as it is about heat. While radiant panels take care of the heat in the air, a dedicated outdoor air system is essential to handle humidity in the space. Along with dehumidification, the dedicated outdoor air system accomplishes ventilation and filtration. The air quantity requirement in this system is much lesser when compared to a typical air-based cooling system. Together with a dedicated outdoor air system, radiant cooling can completely address the thermal comfort requirements in any climatic zone. Using heat exchangers in the form of chilled water carrying pipes embedded in floors or walls or ceilings or in panels ensures the availability of a much larger area for heat exchange compared to a regular heat exchanger, which is impeded by space constraints. Sufficient cooling can be achieved with higher chiller operating temperatures, which in turn results in a higher coefficient of performance for the chiller and consequently lesser energy consumption. A room with a regular air-based cooling system has a higher mean radiant temperature and therefore needs a low room air temperature to make the occupants feel comfortable. A radiant cooled room, however, has a lower mean radiant temperature and can provide the same cooling effect at a relatively higher room air temperature. In radiant cooling systems, which have a dedicated outdoor air system as well, the air requirement is considerably lesser than a regular air conditioner, which is also reflected in the reduced power consumption of the overall system.